Kyung from Samsung Electronics, and nice to meet you. At this time, I propose a method for obtaining gesture-dependent depth imaging for time-of-flight 3D camera with a low resolution. Samsung has all rights of this document. I proceed this presentation with these orders. Introduction of 3D consumer electronics, time-of-flight 3D camera was used at this experiment, and proposed method and experimental result and conclusions. 3D in consumer electronics. The incredible growth and success of 3D film, for example, Toy Story and Avatar, coupled with the public's eagerness to bring the movie theater experience home, has stimulated an exciting stream of innovation, helping to put 3D technology into more consumer devices than ever before. The first product in the consumer electronics market to receive the 3D treatment for televisions and Blu-ray players. Throughout 2010, most major manufacturers rolled out 3D-enabled TV sets. The need for 3D technology is not spreading for all industries: mobile lighting, entertainment, security and safety, automotive. I shortly explain about TF depth sensor. The main concept of TF camera is very simple. A time-of-flight camera is a range imaging camera system that resolves distance based on the known speed of light, measuring the time of flight of light signals between the camera and the subject for each point of the imaging. Modulated light is emitted from the light source, then sensor receives the reflect signal of that. TF sensor calculates distance by measuring phase shift between emitted modulation signals and reflected signals. By changing modulation frequency, we can control the cover range of camera. Time-of-flight sensor is widely used in various applications such as interactive digital entertainment, consumer electronics, and robot navigation system. Fast acquisition of depth is tense real-time application. But unfortunately, conventional TF camera provide depth maps with relatively low spatial resolution, which limits the practical uses of sensor in real-time application. There were efforts to enlarge resolution using some kinds of upsampling methods, but these approaches are not appropriate for real-time application because complexity of calculation. Okay, let's see the short clip. This clip was made by Samsung Electronics to present TF one-chip solution to customers. You can have experience like that. Actually, this clip made me research purpose method. So what do you feel about this? A man is sitting on the sofa and control TV and play games. Play game is okay, but how about the control TV? Was he scroll and push the button easily? I think it looks very uncomfortable. Raise your hands, bending arms, incompetent to drag and push the button. It might be caused the shoulder pain. Let's guess the place where TF camera would be used. left top figures express the general living room conditions. Sofa and TV are located within 2.5 meters, and you have only one tube camera on the TV, and you want control TV or play game using that. What's the big difference between game and tube control? Is size of gestures. General games need big gestures, but to control TV easily, tube camera should get the hand gesture information relatively smaller than that of game. However, typical tube camera which has lower than QVGA size sensors cannot detect fingers in 2.5 meters. It means that typical tube camera could not cover various applications at the same time, which have different useful range, different angle of view, different size of body part being used to operate, and different size of the movement. Proposed methods solve these issues very simply. Tune the angle of view depends on the gestures. This is the processing scheme. It has roughly 3 steps. Scene analysis, find meaningful gestures and zooming and focusing on them. Scene analysis is by 2 steps. First, divide the frame several subzones, and next, classify fore and background. Zooming and focusing procedure divide adjusting optical axis and angle of view and focusing quickly using depth information. Scene analysis. A frame is virtually divided several subzones. One or couple of zones will be the target position where tube camera focused finally. The size and configuration of subzones depend on the specific application. Foreground and background are segmented in-depth image using intensity data. At this step, pixel factor corrections, system factor correction, and outer factor corrections are conducted. Actually, this step is the most important step. Visual 3D data is more noise than 2D color images. Prime pixel correction is procedure that rearranges unstable pixel data at the edge of object. Unfolding procedure is the step that corrects distance data. As I mentioned before, operating range depends on the modulation frequency. For example, assume that we use 12 MHz modulation frequency, which has 7.5 meters operating range. In this case, the result of distance of object located in 8 meters from camera will be expressed 0.5 meters. We have to correct these conditions. Ambient light corrections. Typical tube camera use IR rays as light source. As you know, there are so many IR sources in our environment. We also remove unaesthetic IR source. Next, find meaningful gestures. It's a frame-based calculation. At this step, we get the 2 parameters, activity mass and activity range. We can find the zone where informative activity occurring among the subzones by activity mass. Activity range parameters indicate the size and the range of activity. Analyze those 2 parameters, we can realize where and how activity occurs. Zooming and focusing on the gestures. Actually, this step is on the materializations. At this step, calculate zooming ratio and reassign intensity correction information. Linearity correction adjusts the correlation between the intensity and depth data. This is our experimental results. The experimental condition is a man is sitting on the chair and his hand stands at 2.7 meters apart from the tube camera. Minute movement is opening and clenching hands like this. You see that a frame is virtually divided into subzones which have same size and shape. Minute movement is being occurred at number 7 subzones. activity mass is large at number 7 subzones. This is zone numbers and 7 zones. Addition to this, number 8 and number 12 and number 13 regions have higher score of activity mass. It means that an object is located in the middle of left side of camera. According to activity range, main activity is occurred at about 2.7 meters from camera. According to our experiment, fingertips should be spaced at least 4 by 4 pixel size. It becomes our target size. As a result, at the adaptation of proposed method, right hand is magnified as much as each finger's movement can be detected sufficiently. The proposed method divides the depth image into multiple subzones for the fast extractions. The degree of movement is measured by the difference between the previous and current frame. The experiment visuals shows that gesture-dependent depth data are extracted clearly. Further studies are realization of a cost-effective tuning system and development of robust and intelligent motion analysis algorithm. Thank you.
Thank you very much, and thank you very much for keeping the time that strict. So even though we have a problems with the machine, we have time for 1 or 2 questions. Yeah.
We're talking about low resolution time of flight camera. So
yeah.
What exactly is the resolution?
Resolution, typically the current tube camera has the low resolution than QVGA image. Can you understand? Yeah. Yeah, very low resolution, spatial resolution.
I also have one question. How long does the convergence, including your refocus and changing of the modulation scheme, take? So do you need a longer gesture to be really able to detect it, or does it run instantaneously?
It really depends on the application. For example, if we use this system to gain the fast actions, the frame rate should be higher. And the low motions, we can slow down the frame rate. Actually, in these days, we developed 60 frames per second.
Yeah, my question refers more to the algorithm, because I mean, you need some time to find out how to focus, how to change your modulation to operate in the right depth range. For example, for the hand gesture, right?
Mm-hmm.
Because you must do it on the fly, or did I get it wrong? I mean, because you don't know where the guy sits in front, so you're adjusting your system on the fly, right? So that means it takes some time until you recognize the hand and then say, okay, this is now in 2.5 meter. So how long does it take? Do you need to train the system? Let's say I'm sitting on a sofa and I need to train the system first, or?
Very shortly. About,
yeah, what does very shortly mean? Is it just one gesture, or is it not noticeable? So you just sit there and do something and it reacts?
6 frames.
Oh, 6, yeah, that's fast. Okay. Good. And how many frames for typical gestures? You say you now make 60. Would it be possible to like interleave different gestures? So because you showed that you have 2 different scenarios: local gestures like by the hand and the big gestures from the body. I mean, if you do 30 frames with a focus on the smaller gestures and 30 interleaved frames with the bigger focus, couldn't you do both in parallel, quasi?
This application for humans. Humans didn't make quickly 30 minutes fast and 30 frames very fast. Humans can't do that.
No, but you can have a game, and then within the game control something with a hand or not. So you really say it's 2 modes, right? It's the body mode and the gesture. Okay. Any other questions popped up? None? Then thank you very much again for your presentation. And the last presentation is from Germany. Actually,